In August 2011, NASA's Juno spacecraft began its long journey towards the solar system's largest planet, Jupiter. The aim of the mission was to improve our understanding of the solar system by revealing the origin and evolution of the gas giant. Juno was equipped with an advanced payload of scientific instruments that were designed to investigate the existence of a solid core, map Jupiter's intense magnetic field, measure its atmospheric composition, and observe the planet's magnificent aurora. Juno was built to withstand the harsh and unforgiving environment that surrounds Jupiter, such as weak sunlight, extreme temperatures, and deadly radiation. But before Juno could begin its exploration of the gas giant, it would first have to get there, and so was placed on a trajectory that took it beyond the orbit of Mars, where it performed 2 deep space maneuvers that brought the spacecraft back to Earth for a much-needed gravity assist. Juno passed Earth in October 2013, gaining a boost of more than 8,800 miles per hour, or 14,162 kilometers an hour. The flyby allowed the mission team to test and calibrate certain onboard instruments in preparation for the main mission ahead, which meant they were able to capture some amazing images of our magnificent planet and moon. This time-lapse video is made up from a sequence of images captured by Juno's Star Tracker system, which is a type of compass that can provide the precise orientation of the spacecraft when traveling through space. The grainy, overexposed video reveals the Earth and the Moon as Juno slowly approaches over the course of several days. Although this camera was not designed for imaging planets, it still provided us with a unique view of the Earth as Juno passed by and completed its gravitational slingshot. This enhanced image was taken using the Juno Cam, a camera that is designed to take highly detailed colour photos as if you were there looking at the object with your own eyes. The mosaic was assembled from 82 photos as the spacecraft spun around the Earth, providing us with a spectacular snapshot of our home. You can see the Argentinian coastline that is being partly shrouded by thick clouds to the upper left, as the sun's light reflects off the deep oceans that flow across our magnificent blue planet. Now travelling at a speed of nearly 93,000 miles per hour, or 149,000 kilometers an hour relative to the Sun, Juno disappeared into the darkness of space and entered a phase known as the outer cruise. During the outer cruise, Juno was mostly placed in safe mode, which shut down all non-essential systems while the spacecraft continued on its long journey. For just over 2 years, it travelled further and further away from Earth, heading towards the outer solar system. Then, in January 2016, Juno began its final approach to Jupiter. During its final approach, Juno captured this unique time-lapse video of Jupiter and its Galilean moons. The video is made up of a sequence of images that were taken 5 days before the spacecraft arrived, putting Juno more than 3 million miles or 4.8 million kilometers away from the gas giant. The innermost moon is the volcanic world Io, then the icy Europa, the massive Ganymede, and finally the heavily cratered Callisto can be seen orbiting just beyond. In July 2016, 5 long years after its launch, Juno finally arrived at Jupiter, and at the time was travelling faster than any human-made object in history, a blistering 129,000 miles per hour, or 208,000 kilometers an hour. To slow down, Juno fired its engine and performed a delicate maneuver, eventually placing it into a carefully designed elliptical orbit that allowed the spacecraft to slowly examine the planet while minimizing its contact with harmful radiation, but also making sure that it was fully exposed to sunlight throughout the entire mission. In August 2016, Juno successfully completed the first of many orbitable flybys, which are known as perijoves. It was able to capture lots of scientific data, including many incredible photographs. This enhanced image gives us a glimpse of Jupiter's North Pole from around 48,000 miles away, which is 78,000 kilometers away. You can see magnificent blue cloud structures that are unlike anywhere else in the solar system. Huge storms are visible raging in bizarre patterns, and Jupiter's famous brown bands of clouds can be seen circling towards the planet's equator. Juno was also able to capture Jupiter's poles in infrared light, which is normally invisible to human eyes unless we use a special instrument, such as Juno's onboard Jovian infrared auroral mapper. This remarkable image is of Jupiter's powerful southern aurora, a phenomenon that had never been observed in this way before. Scientists do not fully understand what drives Jupiter's strongest aurora, but Juno has hinted that it may be generated from processes that are occurring deep inside of the gas giant, rather than from the sun's energy, which is what mainly powers the aurora here on Earth. Because of Juno's specially designed orbit around Jupiter, the spacecraft can fly extremely close to the planet's atmosphere, sometimes travelling only 3,100 miles or 5,000 kilometers above the cloud tops. This allows Juno to collect the best possible data, including many incredible close-up images of Jupiter's magnificent swirling clouds. Although they may look flat, the clouds in these enhanced images extend down for many miles. Instead of a hard rocky surface, Jupiter is wrapped in a thick layer of clouds that are mainly made up of ammonia ices, ammonium hydrosulfide crystals, and ice water vapor. In general, the darker material that can be seen in these images are deep, dense clouds, whereas the brighter areas tend to be clouds that are much higher up. The vivid colours may be plumes of sulfur and phosphorus gases rising up from the planet's warmer interior that mainly consists of hydrogen and helium, which becomes more and more condensed the deeper you go, gradually compressing from a gas into a strange liquid. What we can see in these images is a remarkable, colourful, complex tapestry of swirling clouds that violently roll around the planet. And with no solid surface, gigantic storms can form that rage on for sometimes hundreds of years. This incredible infrared image was also captured using Juno's Jovian infrared auroral mapper instrument, and reveals Jupiter's chaotic North Pole region in a way that has never been observed before. At the centre, an enormous cyclonic storm is visible that is surrounded by a ring of 8 slightly smaller cyclones, all spinning in a strange formation. The surrounding storms range in diameter from 2,500 to 2,900 miles across, which is 4,000 to 4,600 kilometers across. This means that just one of these storms is nearly big enough to engulf the whole of North America. However, none can match the solar system's most iconic storm, the Great Red Spot. This enhanced image is made up of 5 photos that were captured by Juno in July 2017 and gives us an incredible close-up view of the Great Red Spot as it churns within Jupiter's swirling atmosphere. The Great Red Spot is a giant anticyclone that rotates counterclockwise in the southern hemisphere of the planet. and it is so big it could consume the entire Earth. As of March 2020, Juno has been orbiting Jupiter for nearly 4 years, while beaming back thousands of amazing photographs and hundreds of gigabytes of incredible scientific data, providing scientists with enough information to last a lifetime. But the mission isn't over yet, as Juno will continue to explore Jupiter from orbit until at least July 2020, so we can expect to see many more stunning images going forward. However, when Juno does reach the end of its mission, it will perform a controlled de-orbit that will take it directly into Jupiter's atmosphere, disintegrating the spacecraft and preventing the risk of contamination to one of the many moons that orbit the gas giant. Although the Juno mission will eventually come to an end, currently the instruments on board of the incredible spacecraft are still operating normally and are continuing to return groundbreaking data on our solar system's largest planet, the mighty Jupiter.